Okay, we're going to start recording, and I'm going to share with you. Share. Okay, can you see my agenda screen?
No.
No. Okay.
Yeah.
Now we see it.
Whoops, nope.
Now you did. Okay. Well, you're going to see it again. Okay. Now you can see it, right?
No, I can't.
Maybe you have for a second.
Oh, you can't see it now?
It's
No.
behind
No.
all of it.
I'm going to stop sharing. And I'm going to share again. Can you see it now?
No. Yes.
There we go.
Okay, you can. Okay.
Mhm.
So everyone can see it? Kathy, you can see it?
Yes.
Okay, good. Okay, so we're going to review quiz number 6 that we took last week. We'll review homework in chapter 6, lesson 1, 2, and 3. The lecture today is on quadratic equations and some algebra solving, problem solving, and I'll talk a little bit about that when we get to it also. But some of that algebra problem solving, I'm not going to have you do. It's just, anyway, it doesn't make any sense. And then we'll do a little work on problems that are due and homework, and then we'll do quiz number 7, and I'll do a little prep for quiz number 7 too. Okay, it was just what we did last Monday, so I apologize for not having, you know, a day, anyway, a day between the quizzes, but I'd like to keep up and just do the quizzes each Monday morning, if that's okay. If this was a regular class, what I would do in these quizzes, I would have probably 3 weeks of quizzes, then I would have a midterm, and the midterm would cover everything in the quizzes plus more. And that's the way and then I would have another 3 weeks and I have another midterm, and then I would have a final at the end covering everything. So it all builds on these quizzes is what I'm getting at. So it's important to understand how to do the quizzes. The quizzes are based on the homework. And of course, the homework is all assigned. So it's all pretty methodical and not meant to be confusing to anybody, but that's the way I run my classes. So having said that, let's jump into the quiz. Quiz number 6, the key is posted on Canvas, and we'll go over page by page. Okay, problem by problem here. I gotta find it. Sorry. Quizzes is right here. I want the key. So I'm gonna go here. Okay, so can you see my key now?
No.
Can anybody see it? No?
Now you can.
There it is.
Okay, thank
Yep.
you. Okay, so you guys didn't do too bad on the quizzes, on this quiz. I did pretty good. Okay, so it wasn't too much that was missing. Okay, the first one was identifying pairs. The reason we want to understand that is because that's how we can collect and that's how we can simplify things, is by combining pairs, okay, like pairs. And so when you see 11y and minus 3y, they both have the common variable of y, just with a constant that's different. So obviously you can combine these, okay? They're like pairs, I can combine those. Unlike pairs, you've got an m and you've got an m to the second power. You can't combine those, okay? Simplify each expression, and again, we're just combining like pairs, okay? In this particular one, I've got an 8x to the second power y, and I've got a minus 3x to the second power y, so I can combine those. I can combine the 4y, minus 4y, and the minus 9y, right? I can't combine the 3x and the 10 is all by itself, okay? Same thing with this one. I'm combining the x squared values. I'm also combining the x values, okay? This was just to simplify and show how many pairs you end up with, or how many terms, excuse me, and you end up with 3, okay? This one was adding again, we're adding like pairs. That's what we're doing here. The 9x squared, the 7x squared, 16x squared, and so forth. And you end up with a parabola. Okay, and we'll talk about parabolas today, our quadratic equation. Okay. Here you're again adding like pairs, and the only like pair you're adding are the constants, right? The -3 and the +4. Here you're subtracting polynomials, so I have this minus sign here, so everything inside that bracket, the sign would change, right? If it was plus, it would end up being minus. If it was plus, it would be minus. If it was minus, it would be plus, because a minus times a minus is a plus, right? Okay, same thing on this one. Any questions on these at all? Pretty straightforward. Take that as okay. Okay, multiplying the following monomials. So we're multiplying 3x squared times 2y. So when you do that, you just have x squared times y, and then you multiply the constants together. 3 times 2 is 6. Same thing on this one. They're all different terms. So you can put them in any order you want. But, you know, there's any order is fine. Here you're multiplying a monomial times a binomial. In other words, one term times two terms. And you just want to make sure you multiply all of them. I mean, don't miss anything. And same thing with this one. Okay. Here you're using the FOIL method to multiply two binomials together. And today we'll talk more about the FOIL method and how it's used, and then factoring, working backwards. In other words, going from this answer down here, 6x squared plus 29x plus 35, and factoring it back to this, something like that. And we'll practice that today. Again, FOIL method, first, inner, outer, last. I mean, you can memorize that. The important thing is to make sure you get all four combinations, right? And I always just do it like I've done it here. This one times this one, first times the outer, the two inners, and then 5 times both outers. Okay. Divide each polynomial by a monomial. The 2 has to be divided into both terms inside. That's why I broke them out like that. And then went ahead and factored them. It becomes y plus 2x. Same thing with this one. It becomes 6b over 3 plus 12c over 3. Again, do the factoring. 3 goes into 6 2 times, so it's 2b. 3 into 12 is 4, so it's 4c. Okay. More dividing polynomials. And here you can determine whether you're going to split or not, but in this particular one, it makes sense to split. I put 3x into 3x squared. And when you divide the 3x into 3x squared, that x to the 1 power cancels out 1 power up here, so the answer becomes x. This one, the x cancels out x, so it just becomes 6 divided by 3, or 2. On this particular one, I'm dividing I'm splitting it up again. I'm taking this term and dividing it by y minus 2. And I'm doing this because I see the y minus 2 is a common binomial, which will factor out, right? So that cross that out, so we end up with x. This over here, 6 times y plus 2, the y minus 2 will cancel out the y minus 2, so it ends up being 6. So the simple answer is x minus 6. Okay. Any questions at all on those?
Number 10B,
Yep.
was that an absolute value one?
No,
You
that's
have
just a double. It's a double. What am I trying to say? Parenthesis. It's
Oh,
outside
okay.
one is just a different version, Jessica, of a parenthesis.
Yeah, yeah.
Okay. If it was a vertical line, then it would be absolute value.
Oh, okay.
That's
Gotcha.
the difference. Okay, but good question. Anything else? Okay, we'll stop sharing that. And go back to the agenda and review any homework problems on chapter 6, 1, 2, and 3. Anything you want me to look at, particularly because the quiz is on this stuff today. Okay, that's what it's on. So I'll be glad to look at anything you want to look at.
Can we go over on page 355,
Sure.
question number 11?
Okay, just a minute. I'll get her. 355, number 11. So let me check it out here. Share the screen. So week 7 to
What page is
55.
that?
355, I think she said.
Oh, okay.
So let me
Number 11.
stop sharing, share, number 11. Must be right here. 2, 2, 2. Okay, this one right up here, 5 times 2x minus 10 over 2.
Yes, that's it.
Okay, so we're solving for the variable. So what you want to do in this one, first thing you want to do is multiply every term by 2. Just get rid of this 2 down here. That's what I would do. It's a simple, I mean, you can do it a couple different ways, but that's the direction I would take. Let me write that problem down and we'll look at it on the board here just a minute. 5 times 2x times 10 over 2 plus 14 is equal to 19. 2x minus 10. Okay, so let me have the problem. Let me stop sharing that. First of all, get this guy up here. Okay. Share the screen. Okay. So here's my screen. So that first one, lost it just a minute. Oh, it's way up here. Okay. It's hard to, okay. 2x minus 10 multiplied by 2 plus 14 equal to 19. So what I said, I would multiply everything by 2. So I get the 2 out of here. I'm not going to factor. I could. My first gut reaction was to multiply everything by 2, get rid of that denominator. I could do that, or I could divide the 2 into there and 2 into that. But I'll multiply everything by 2 because that's what I said I was going to do. So what that means is I'm going to have 5 times 2x minus 10. And the second term, I'm going to have 14 times 2. Do this right. Okay, does everyone see what I did here?
Yeah.
I've multiplied every term by 2. And this first term, that 2 will cancel that out. So I end up with this. Does that make sense? Kathy, do
Yeah.
you see what I did?
Yeah, I can see what you did. I'm just trying to figure it all out.
Okay, but I mean, that's the first step.
Okay.
And then the next step is to go ahead and multiply 5 times 2. So it'll be 10x. And 5 times minus 10, which will be minus 50, right? Oops. And then 28, that's what 14 times 2 is. And that will be equal to 38, right? So
Yes.
now it's just managing doing simple algebra, putting these terms on this side and then figuring out what x is, right? So it's going to be 10x. I'm just going to move the 50 over, so it's going to be a plus 50. I'm going to move the minus 28 over, so it's going to be minus 28, right? And the 38 is already over there, right? Plus 38. Now I'm going to combine those terms on the left-hand or right-hand side. So you got, let's just do the simple part. The minus 28 plus 38 is plus 10, plus 10 plus 50 is 60. So it's 60, right? So now I'm going to divide both sides by 10. And so x is going to be equal to 6. That makes sense?
I don't get that at all. I'm
Okay,
sorry.
well, okay, well, wait, what do you where did you not get it? The second line or the third line or what?
Probably on the fourth line when you say 10x equals 50.
Mm-hmm. I added 50 to both sides so I could move this minus 50 over to the right-hand side. That's what I've done to get to 50 on the right-hand side.
And then 50
And then, yeah,
track
go ahead.
28.
And then
and-
the 28, I added negative 28 to both sides so I could cancel this out. So I get negative 28 on the right-hand side.
Okay.
And then the 38 is already on the right-hand side, right? I'm just simplifying it. It's hard, it's cumbersome to do this with this thing here. But you see what I did?
Yeah.
I added 50 to both sides. I added negative 28 to both sides. And when I do that, I end up with this term right here. I mean, this expression right here. So now I just collect the terms on the right-hand side. I know that minus 28 and plus 38 together is plus 10. Plus 10 plus 50 is plus 60. I just try to make it simple. I mean, I calculated it simple. Okay.
Yeah.
So that now the last step is just divide both sides by 10, right? You see that, right?
Yes.
And, if I, where's my little scribe here? So I've essentially taken, I don't like this, I like a thicker line. Can't see it. I'm divided both sides by 10. That allows me to cancel that out. And so I end up with x is equal to 6, right?
Right.
Okay, that's how you do that. Okay, any other questions?
Can you do number 3?
Sure. Okay. Okay, number 3, 6m is equal to 14m minus 16.
Yes.
Okay, I'm going to write it down so I can put it on my board here. Just a minute. 6m is equal to 14m minus 16. Okay. So, stop sharing that. Back here. Okay. Gonna get rid of this stuff. Start over. And it was 6m is equal to 14m minus 16, right?
Right.
Oh, well, I don't like those capital M's here. Usually variables are small letters. Okay, so you've got that. So what I would do is I would subtract 6m from both sides. So I get I go positive on this side. You can do it either way, but I would say 6m minus 6m is equal to 14m minus 6m minus 16. Okay, so why have I done it that way? So I'm going to end up with a positive number. So what I'm show you how. Trying to use my scribe to do. So then this becomes 0 on this side, right?
Right.
And this over here becomes 8m, right? A positive 8m, right? That's why I took away. I could have done it. Yeah, I could have subtracted minus 14 from both sides, 14m, and I would end up with a negative 8m over here. Okay, but I just chose to do it the way I did it, so I end up with a positive variable. Okay, so now it looks like this, right?
Right.
So now what you have to do is and this is equal sign. So now I have to add 16 to both sides. So I have to get that variable all by itself on one side, either left side or right side. It doesn't matter. Okay. So at this point, I'm just going to add 16 to both sides. Okay. So now I've got 16. Oh, sorry for my chicken scratch here. Just not doing too well. 16 is equal to 8m, right? So the last step is just to divide by 2 or divide by 8 on both sides, right? So now I've got 2 is equal to m. And normally you would flip it. You'd put the variable on the left-hand side. So the last step would be saying m is equal to 2. Okay. That makes sense, Kath? Where were you confused on that? What part?
The whole thing, I mean, I don't get the 6m, subtract 6m. I mean, I can understand that that goes to 0, but how does
Yeah.
it equal 14?
It doesn't equal to 14. No,
No, she means the M part.
well, this is 0 on this side, and this is 8m on this side.
I know, but when on the very first line, 6m equals 14m.
Oh, okay. Well, that's the expression, or that's the equation, right? That's what it was in the book, right?
Right. No, I understand that, but I just don't get it.
Well,
Because
there's
it's
a
like,
value. Well, here, because if I go ahead, Kathy, and put this 2 back in here, you're going to see that 2 times 6m is equal to 12. 2 times 14 is equal to 28. 28 minus 16 is equal to 12. 12 is equal to 12. Let me do that a little slower, but that's checking it. So it does work. Maybe it looks weird, say, how can 6m equal to 14m, right? Well, it can only equal if you've got this negative 16 in here. It does equal. So what I'm saying is we got the answer of 2, right? So
right.
part of these things was to check. I said, well, check your work. How do you do that? You take that 2, put it back in for m. So if you say 6 times 2 is equal to 14 times 2, right? Minus 16. Sorry. So on the left side, you've got 12. The 14 times 2 is 28, right?
Mhm.
Minus 16. Well, 28 minus 16 is 12. So 12 is equal to 12. So therefore it checks. That's the only value of m that works in this equation. Okay?
Yeah.
That's why it works. I understand what you're saying. How can 6m equal 14? It can only equal if you've got this in there. If you didn't have there, it wouldn't make any sense. I agree with you. Okay?
Yeah.
That's the way you have to look at them. And when I say check your work, that's what I want you to do. Put that value you got back into the original equation. Make sure it's balanced. Okay? Because there's some of these on the quiz. And I'll go over that a little bit too, a little bit more.
Okay.
Does that make sense now, Kathy?
Yeah.
Okay. Okay, any others to look at? If not, I'm going to give you a couple hints on the quiz. So, no, this is okay. The quiz. So just like we did on that, you have to solve for the, when I say solve for the variable, you solve for the unknown, right? So if I had a deal like, I'll go back to here. And we'll just get this out of here. Like I say, the quizzes is just going to reflect the homework, okay? And if you ever take my class, that's the way they're all handled. I do them all like that. Some teachers don't. I mean, everyone's got their own preference on how they teach, but this is how I teach. So it's important to do well on the quizzes is what I'm getting at, to understand it. Even though we're not getting a grade in this class, I want you to understand it, and I want you to be disciplined and to figure out how to do this stuff, okay? That's what it's all about. So when I say solve for a variable in each case, so if I had a simple thing like this, if I had like 12x divided by 3 is equal to 24. And I say, okay, solve for the variable. What that means is solve for x. So in this particular case, I would want to multiply both sides by 3 to get rid of this 3 on the bottom, right? So it becomes 12x over 3 times 3. And if you do it on that side, I have to do it on the other side, right? It's still balanced. The equation's still balanced. I've just multiplied both sides by 3. But it's allowed me to get rid of this denominator of 3 here, right? I realize it's hard to, I wish I was on a board. By doing what I've done, this 3 is on top, this is on bottom, so it cancels it out, okay? So now I've got 12x is equal to 24 times 3. 24 times 3 happens to be 72, right? 24, 48, 58, 68, 72, right? Now I'm going to divide both sides by 12. What's 12 into 72? Anybody know? It ends up being 6 times. Okay, so x is equal to 6. Okay, so now I say check your work. Boom, you got to put that 6 back in there. So when I say check your work, I want you to put 12 times 6 divided by 3 is equal to 24. Now do the math. Factor 3 into 12 goes 4 times. So now it becomes 4 times 6 is equal to 24. 4 times 6 is 24, is equal to 24. Boom, it checks. So this is the right value in here, right? I just proved it. That's what I mean by checking, okay? Got to check your work. If I say check your work, okay? Okay, questions on that? Pretty simple. I mean, hopefully it's pretty straightforward, okay? I don't want to use the word simple, not simple. And there's a number of those to do like that, where you just have to do the algebra, solve for the unknown, okay, and then check your work, okay? Okay. There might be there's a couple problem statements where you put an algebraic expression down based on a sentence or two. Like if I said the difference of 3 times a number, less something is equal to a number plus a quotient, you should have enough information to be able to do that. And I'll do one for you. Okay, let's do one. And some of these are, I don't want to make them really complicated because I don't think you're not really going to learn math that way. I don't think so. Anyway, so if I said write a problem statement as an algebraic expression, I'm not saying solve for it. I just want you to write it down. So when I say if I said the difference of 3 times a number and 2, if I said the difference of 3 times a number, well, that would mean 3 times a number, represent the number by x. You don't know what it is. And 2, 3 times a number, and that's that expression represents the difference, okay, of 3 times a number plus 2. And if I said that is equal to, I could say that is equal to 15. I would just say that's how you'd write that expression. That makes sense? So you have to know when I say the difference, it's always a negative. And of course, when I say it's equal, there's an equal sign there. When I refer to a number or something, just refer to it as X or Y. I'm not saying solve for it. Okay, there's another one like that too. So there's 2 like that, okay? It won't get any more complicated than the 2 that are on the quiz, okay? You can use your notes too. I'm saying use your notes. Now, you get in the real world, when we do this, if you take Math 66 with me, you won't be able to use your notes, okay? To study it and understand it enough to do it, okay?
Can you do another one?
Certainly, yep. I'm going to do sort of the same flavor. I'm going to say okay, I'll use a quotient in this one too. Okay, the difference between 5 times a number and 15 is equal to the quotient of the number and 3. So the left side, the difference between 5 times the number and 3. So you would say 5x minus 3, and it says it's equal to the quotient. When you say the quotient of the number and 4, the quotient, the divisor is the top one. You know, remember what that means. Quotient. Quotient is equal to divisor, if I can spell, divisor divided by dividend. Dividend, okay. Great, I can't move it. Anyway, that's what quotient is equal to divisor over dividend. So when I say is 5x, I said the difference between 5 times the number and 3 is equal to the quotient of the number and 2. It would be like that's equal to x divided by 2. That would be the quotient of the number and 2 because it's the divisor divided by the dividend. In this case, the divisor is x, the dividend is 2. Okay, so I'd say 5x minus 3 is equal to x over 2. Then the next step would be to solve for it, but I'm not asking you to solve for it. I'm just asking you to write the expression. Okay. Does that make sense, Jessica?
Yeah.
Okay. Anybody else on that? There's one with a quotient in there. Okay, so understand what that means. It's one number over the other number. That's equal to the quotient. So if I say the quotient of x and 2, it would be x over 2. Okay. Okay. Then the last part is on the inequalities, and I want to talk a little bit about that. Okay. And we talked about inequalities last time. Inequality is just an expression with an inequality sign instead of an equal sign. Okay. So if I said like 2x, I don't think I can do it on here. I'm going to have to do it. All right, just a minute. Yeah, I gotta change hands here, fortunately. So 2x is less than yeah, it's less than 5. What's x equal to in this case? It's just like the same as saying 2x is equal to 5. We're just going to solve for the variable on one side. So in this particular case, you just divide both sides by 2, right? Because then I can get the 2 out of there. Then I can say x is less than 2.5, right? That's 5 divided by 2 is 2.5, okay? And I say, okay, put this on a number line, graph this. What does that mean? You've got a number line, right? Like that's supposed to be a straight line. You know where 0 is someplace along here. And when I say x is less than 2.5, you'd go over 2.5, which is right here, right, on this number line. And it's less than, so it's an open sign. I mean, it's open circle. And this thing goes like this. So up here, you'd say x is less than 2.5, right? That's how you would define that. Questions on that? You see what I'm doing? It's open circle because it's not equal to. I'll do another one, okay? And we'll make a little more algebra intense here. Not hard, but I mean, we had like 4 times y, whoops, y plus 2 is, I'm going to write in less than or equal. And, sorry, less than or equal to, okay? Of course, I lost my thing, so I got a pain. Is equal to, say 7, and a number like 7 in here. So how do I do this? The first thing I want to do is multiply the 4 times y plus 2, right? So I'm going to get 4y, excuse me, plus 8 And then it's back to this less than thing. Let me get over here. 7. And I'm going to go back and I'll. Sorry, I have to use 2 hands on this thing. So that put that thing back in there like that. So now what's the next step? What would I do next? Anybody?
Subtract 8.
Subtract 8, right? Because I want to get the variable by itself on one side. It's just like an equation. Don't be, don't be fooled by that inequality sign. It doesn't change. I'll tell you there's one way it does change if you're multiplying or dividing by a negative. And I'll show you that in a minute. But anyway, this one would be 4y. And so it'd be plus 8 minus 8. And then that sign, and it would be 7 minus 8. Because what I'm doing is I'm getting rid of this, the 8 on the left-hand side, right? And there's a inequality sign in there. So I'll put it back in. 4y is equal to 7 minus 8 is equal to minus 1, right? So in this particular one, this would be your answer. Right? Less than or 1. And I say, okay, put that on a number line. What's that going to look like? Well, I'm not done yet, am I? So I have to divide by 4 on both sides. So when the dust settles, I'm going to get y is less than or equal to minus 1 over 4, right? Minus 1/4. Put that on a number line. Make that 0. Say this is minus 1. Minus 1/4 is right here, right? 1/4 of this. So it's right up here. It's less than or equal. So that's why you put in a deal like that. And it's less than, so it's going to go this way. So you'd write it on top. You'd say y is less than or equal to minus 1/4. Everybody see that? Kathy, does that make sense to you?
Yeah.
Okay,
Yes.
this is minus 1/4 here. Okay. Okay, I'm going to show you one more, because if we have a negative on the variable, we have to multiply or divide by a -1, and when you do that, you flip the sign. Okay, and I'm not going to get into prove it, but it does work, honestly. So just remember that rule. Many high school kids get tripped up in this thing all the time, so it becomes a real issue. So if I said minus 5x plus 3 is less than or equal to, and I could put like 2x on this side. You can always do this too. You can have that variable shown in a number of places, but you want to collect it when you're done. Okay. So if I had a deal like this, okay. So first thing we want to do is collect our variables. So I'm going to move this. I'm going to subtract 2x from both sides, so I get minus 3x over here. Okay. So this one now becomes minus 3x. And I'm going to subtract minus 3 from both sides also. Now so I've got minus 3 over here, so I've got minus 4. So this thing looks like this. Okay, so minus 3x is less than or equal to minus 4. Okay, so now we want x. We don't want minus x or minus 3x. We want x. So that means I have to divide both sides by -3, right? I'm going to do that. Put my pin here. I'm going to take this. I'm going to divide both sides by -3. Like that. What this does for me, I get to cancel that out like that. So now I've got x. But when I multiply or divide by a negative, I flip this sign. So this thing becomes like this now. I just flipped it, right? Instead of less than or equal, it's greater or equal. And -4 divided by -3 is just 4 over 3. Right? Does that make sense? That's what you have to do if you multiply or divide by a negative. And I know I went over this very briefly last time, so that's why I'm taking a little time to do this. This is 0, greater or equal to 4/3, so that's 1 1/3. So if this is 1 and this is 2, the 1 1/3 is right here. So you do it like this, greater or equal, so it'd be like this. You say x is greater or equal to 4/3. Okay. This is 4/3 over here. That makes sense? Anybody?
And it becomes positive because,
Yeah, because I had to flip it.
right.
That's why I get less than or equal and I change it to greater or equal. That's what you do. I think there's one where you flip, okay, on the quiz, okay? That's how you do it. So please write that down and make a note that if it's multiply or divide by a negative, you flip the inequality sign, okay? Okay. Okay, so I'm going to stop that and we're going to go on to the lecture for today. Okay. Okay, and okay, let's see, I gotta find it. So it's week 8, 16th. Stop sharing, share. Okay, quadratic equations. It's a shame we're only really spending 1 or 2 days on this because you could spend a lot of time on quadratic equations. If you take the technical series, you really don't get into quadratic equations until Math 95, and there's quite a bit of it on there. There hardly is. There's very little in 60 and 65, and you won't see it in Math 58 either. But anyway, we're doing it, okay? Just a broad brush of everything in here. So a quadratic equation is defined as an equation where one variable has a second power on it, okay? It has to, if this equation was just minus 3x is equal to 4, that would not be a quadratic equation. If it's x squared minus a variable is equal to 4, it would. Or if it's just x squared is equal to something, it is. Quadratic equation will always have a component in there that has x or something, a variable to the second power. And it won't have anything with 1 over x in it or x to the negative power or anything like that. It's just x squared. Okay, that's a quadratic equation. Why is it so important? Because it produces a parabola. Why is a parabola so important? Because it's used in physics. It's an equation that's actually used to determine the height of a rocket, how far something will travel downstream and everything. So it's really an important function to understand and graph and use. And you actually use it in the real world if you do math. Okay, so it's really important. That's why quadratic equations is really important. Okay, when I say factor something, it's like put it down to its simplest terms. In this particular case, it becomes like 3x times 5x plus 3 is the same as this 15x squared plus 9x, but we factored it down to the lowest terms. We do this in the math world so we can actually determine what the roots are, the roots of this equation. And I'll get into that a little bit too, okay? You'll understand it. Here's a better example of a quadratic equation. This is in the factored form. 2x plus 3 times x minus 4. If you use the FOIL method, you're going to end up with this thing right down here. 2x squared minus 5x minus 12. It's the same thing as this. We've just multiplied it all out, okay? And I'll show you why that's so important. In fact, I'll just go ahead. Yep.
So it's like doing the reverse of what we did last time,
Sort of, yeah.
combining it. Now
Yep.
we break it down.
Yep. Now we're breaking it down. And why are you doing that? We're doing that so we can figure what the roots are. We're figuring out the roots are because that's used in mathematical expressions to determine how far something goes. And I'm gonna share you another screen with you so you understand what I'm talking about. couple different ways. I'm going to share. I think this is the one. No, that's not the one I want. Okay, just a minute. Maybe just graphing parameters. Okay, yeah, this is probably good. And then I'm going to show you on a software program to show how to do this. So if this is a parabola, it's got, you put it in this terms where ax squared plus bx plus c is equal to 0. You've set everything equal to 0. Okay, and you look at what your a, b, and c those terms are, and that's how you.
We don't
Yep.
see your screen.
You
You need to
don't.
like double click it.
Okay, well, sorry about that. Let me. Thanks for letting me know. Now, can you see it?
Yeah.
Okay, so it's
Crap.
sketching parabolas is what it's called. So a positive parabola is something that goes up like that. A negative, it goes down. If this by positive, it means the sign that's in front of the x squared or y squared value is either positive or negative. If it's plus, it goes up like that. If it's negative, it goes down like that. If you're graphing like something that like a rocket that's impacted by gravity, that's negative. So that's going to be a minus something x squared. And if you're graphing something to do with physics, usually that x value is t, that's time. Okay. This whole thing is equal to y, which would be the distance. And then it goes on, you don't have to do this, but when you get into math 65 and 95, you have to know how to do all this stuff. But find the axis of symmetry. The vertex is just the highest point or lowest point on this thing. It becomes really important to understand how to calculate that. So if you can figure, well, how high does that rocket really go? Well, if you have an equation that models the rocket, you can go ahead and figure out how high it goes by this little equation here. It's minus b over 2a. It'll always give you the max height or the minimum height. It's like this or like that. And the y and x intercepts are really important. So I want to share something else with you this time. It's a, I'll have to get to it. Let me see here. View. Here? No. I'm trying to get to my. Okay. Bear with me here. Okay, you probably can't see my screen yet, right?
Right.
Nope.
Okay, so let me. Okay. So now we're going to share. Now I'm going to go and. Darn it, I can't find it. Share. Oh, show all windows here. Okay. So now can you see my screen? It's called Desmos on top. Okay,
Yes.
it's a really neat program. If anybody ever heard of Desmos,
No.
if you type in desmos.com, boom, you'll pull up this free software package you can use. I can model linear lines as well as parabolas as well as other things. So if I said like y is equal to 2x, it'll give me a straight line like that.
Oh, wow.
Right. It's really cool. And if I said, and then we'll talk about this a little bit later, it'll help you determine what the y-intercept is. That's the value of the line when it crosses y value. In this particular case would be 2. That's what that 2 means up there. The slope is plus 2. It's 2 over 1. So it's right here. So it crosses the x-axis at minus 1. But what I want to show you today is parabolas. If I make this thing, let's get rid of this. Let's do another one. If I make it, ahead of myself here. Let's do this over again. Let's go. Y is equal to,
Oh, wow, it's cool.
yeah, but I've got it backwards here. X. There we go. See, if y is equal to x squared, so if I had an expression was just x squared, this would be the parabola for that expression. If I said, well, it's equal to that plus x, it would look like this. If I said it was equal to plus x plus 3, it would look like that. And you can determine your roots from this thing. That's not a good example because by roots, I mean crossing the x-axis. In this particular case, the roots would be -1 and 0. That's where it crosses the x-axis. And that's used, like I said, it's used in physics in all kinds of cases, okay? So it's really important to understand how to use it and why it's important and so forth. That's a parabola, okay? That's a quadratic equation, which is when graph gets you a parabola, and that's what a parabola looks like, okay? And it's important because I can figure out what the square root of this thing is. Excuse me, I can factor this and get what my roots are, okay? And this, let's take one that's in the book. If you look on page, look on 361. And what I'm going to do is I'm going to take that first number 16 there, factor each expression, make that a 4x and plus 3, right? Okay, so can you see my screen? So I've got
Yeah.
y is equal to x squared plus 4x plus 3, right? Okay, you see where it crosses the x-axis. 1 is where x is equal to -3. I've got the cursor right on that line, right? And it says -3 and 0. I put it over here. It says -1 and 0. The -3 and the -1 are the roots of this equation. In other words, if I factor that equation, and we'll do that. I'm going to write this down on a piece of paper here. X squared plus 4x plus 3. So if I can stop sharing that and go to the board, go to my whiteboard. I can find it now. Wrong whiteboard. Right here. Okay. Okay, so bear with me. So we've got this quadratic equation. It's all going to make sense here. Okay. And it is x squared, x, and I'll use the caret to do this, plus 4x plus 3, and that's equal to 0, okay? That's the same thing as y is equal to this function, okay? That's what that means. So I'm saying find the roots of this thing. Well, the roots, if you take the constant, it's equal to, it looks like this. Whoops. Plus something inside there times x plus something inside there. Whoops. Is equal to 0. Okay. So now we want to figure out what the roots are of this thing. We know that the two numbers, the factors of this, what am I trying to say? The factors of this become this number and this number. So in this particular case, factors of 3 are 3 and 1, or 1 and 3. Those are only two different factors. So that means one of these values has to be a 3, and one of these values has to be a 1. Okay? And it turns out that also we know that 1 times x plus 3 times x is 4x. So in this particular case, it looks like this. Okay? So this is the factored form of this value up here. So the roots of this is if I put x equal to -1 in here, this is 0. 0 times this is 0. So it satisfies this equation. So I can say there's two roots here. One is x is equal to -1, right? And look at the second one. If I put in -3 here, -3 plus 3 is 0. 0 times this is 0. So it satisfies it. So it becomes x is equal to -3. Oops, -3. Now, why do you say this is, I mean, what's so unusual about this? What's not unusual, but go back to the Desmos graph we had, you'll see that it crosses at -1, it crosses at -3. It's all related, okay? That's what I'm trying to show you, and so you can understand. So I'm going to stop sharing that. Hopefully I can find that Desmos screen again. No too much problems. Oh, it's right here. So can you see my decimal screen? This is the equation I had, right? And I put my cursor right over here. See, it crosses at -3. It crosses the x-axis.
-1.
And -1. Those two values satisfy this function, okay? And when I factored it, I got those two values. That's why you factor. You can do that. You can figure out what is the x-intercept, where it crosses the x-axis when y is equal to 0. It all makes sense, okay? If you think about it enough, okay? But that's why
Gosh, this was so long ago.
yeah, I know, I know,
Yeah.
but it's still alive and well, okay? So
Yes.
you have to resurrect it in your mind, okay? Okay. That's what that's all about. I wanted to go through that whole little loop for you. So I'm going to stop sharing that, and we're going to go back to the original equation in the book and where we were. Let me find it. And we're going to go back. We're actually just on that first page, but sharing, share, right here. Okay, so you can see my page again. Can you see page 360?
There it goes.
Yeah. Okay. So it gives an example down here. Here's the quadratic equation. You go in, find the roots of this. It ends up being x plus 1 times x minus 4 because you put it into x squared minus 3x minus 4 is equal to 0. You always put it in terms of equal to 0, and that's what they've done here. We'll go through a couple of them to do this,
So you
but
change
go
it
ahead.
so that it always equals 0.
Yeah, exactly.
Okay.
Because what you're doing, you're figuring out what when y is equal to 0, where does it cross that x-axis? That's why it's
Gotcha.
equal to 0. Okay. Excuse me. Yes. So I'm going to stop sharing that. We're going on to the next page and look at some of the problems. There's only 4 pages on this exercise, but there are 3 of those pages are really important. Okay. So. Okay. Here's practice 4 for lesson 4. And like I say, the first 15 of these are all in the root. They're all you've already got the roots, right? And what you're asked to do is figure out what the equation looks like. In other words, do the FOIL method to go ahead and calculate it, right? You understand, like, we'll do a simple one. So let's do number 4 or number 3, right? So I'm going to stop sharing, and we're going to share my screen again. Yeah, one way you're factoring, the other way you're unfactoring, okay? And- all these are equal to 0, okay? Just, you don't really care about that part of it. We're trying to figure out what this, when we go ahead and multiply it together, what do we get? Use the FOIL method, right? So that way you don't miss anything. And we'll, things going on here. I will take, okay, so, whoops, sorry. Okay. So we know FOIL method says multiply that times that, that times that, that times that, and that times that, right? So when I do it, I get x squared, and I do x times 4, and so it's plus 4x. Then I do this times this, so it's minus x. Then I do minus 4 times 1, so it's minus 4, right? So this is how you do the first 14 or whatever it is. You're just doing the FOIL method, right? Multiplying them all out to get this. But make sure you understand how to do this and don't leave out any terms. And so the second step in this, of course, is to add the like terms, right? That's why we talk about like terms so important. So it ends up looking like this, right? That ends up being your answer, right? Okay. And if we're going from this up to this, let's say we're going backwards. Just say you didn't know that up here. Second part, you've got to figure these things out. So it looks like this, right? So what numbers am I going to put in here to make this equation like that? Well, what you know is this, to get this last number, it's going to be a factor of that. It's going to be multiplied. So it's going to be a multiplication of the factors. So you got the number 4. So what's factor of 4 and 1 is 4. 2 and 2 is 4, right? Minus 4 and minus 1 would equal minus 2 and minus 2 would equal. So that's part of it. The second part is getting this inner term, the middle term here. That's adding. Okay? That's adding these two factors together. So you'd know that you could take a 4 and a negative 1. Well, actually, yeah, this is a negative up here. So I want to get here. So it means I either have to have like that or like that, or minus 1 and 4. Some way to get negative 4, right? Multiplied together. But also they have to be some way to add up to 3. So so the only combination here is a 4 and a minus 1 will give you 3. So that ends up being your answer. And sure enough, you put these numbers back up in here and that's what you have. You've got a negative 1 and a plus 4. You see how to do that? We're going to do a few more, but you use this little method here. Multiplying the factors of that last number, adding those factors together to get the middle number, the middle quotient, okay? Okay, not quotient, the middle term, okay? Okay, so I'm gonna stop sharing, we'll go back, and we'll do some more of these, but this is the basis of the whole thing. And why are we doing all this? So we know if we've got a parabola that goes like this, those values define where it crosses that x-axis. That's why you're doing this, okay? And like I say, it's used in physics, it's used in some problems, okay? It's used in business when they put together profit projections and so forth based on algorithms, based on numbers or expressions that have x squared in it, okay? Then you can always do it a parabola and make it work like that. So it's very useful, is what I'm getting at, okay? It's not just a little exercise you're doing to, give you a headache, okay? It's actually got some use to it, okay? So we'll stop sharing that. And we'll go on. I think I probably was there. Okay. God, too many pages here, sorry. We're back to this. So what we said, those first 15, you use the FOIL method to go ahead and crank out the number, right? That's all you're doing here. The second one, you're working backwards. You want to factor each of these expressions, okay? And so let's take another one. Let's do another one. Do each step. I have not done, let's do 18. X squared plus 8x minus, or plus 12, okay? So I've not done these, so we're just going to do them together here. Stop sharing, share, go here. Okay, I'll write down the equation again. It's x squared, x squared plus 8x plus 8x plus 12, right? Plus 12. So that's what we've got. So I want to figure out, the question is, what are my factors to do this, to make that equal that equation? So it looks like that, right? I want to know what numbers I'm going to plug in here. So again, I look at the last term, it's a 12. That means I factor that 12. So I'm going to go over here, I'm going to put 12. And I'm going to, what are the factors that equal 12? Give me some.
3.
3, and what goes with 3? 4, right? 3 and 4 would give you 12, right?
6 and
Same
2.
thing with 4 and 3 would give you 12, right? What are a couple more?
6.
6 and 2, right?
Yep.
And 2 and 6. And what's one more?
1 and 6.
No, 1 and 6
Oh,
will only give you 6.
Never mind. 1 and 12.
1 and 12, thank you. Right? And those are the only ones you really got. You don't have any more. So those are all the factors that give you 12, okay? And they give you a positive 12. Now, I could have two negatives here too. It could be a -3 and a -4. That would give you 12, right? They could all be all negatives too, right? But now you want to look at, well, the sum part of it. The sum of this thing has to equal to 8, right? That's 8x up here. It has to equal to 8. What am I going to get equal to? How do I get 8 out of this thing?
So it would be 4. Wouldn't it be 4?
No, well, how 4 and what?
2.
No, well, you can't, but 4 and 2 don't make 12. These are all the combinations that make 12.
6 and 2.
6 and 2, bingo. So we know 6 and 2 is going to work, right? That's what that, so now we go ahead and plug them in. I have to do this again, I'm sorry. So it's positive, they're positive in this case. Okay. Then you plug them back in. Now, just to prove it, go ahead and do the FOIL method, make sure, this little method works. I mean, are we crazy or not, Probably crazy, but I'm going to work with it. So we're going to use the FOIL method now. I'm going to multiply that. 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 So x times x is x squared. X times 2 is 2x, right? 6x. And then 6 times 2 is 12, right? Now I go ahead and combine those. I got x squared plus 8x plus 12. Okay, does that make sense? By golly, that's what we started out with, right? So this is equal to the one we started out with. Okay, so write all this down so it makes sense, okay? This is what you have to do in all these. Some are easier, but you have to get the multiples, all the factors for that last number. You have to get the sum and then go ahead and do this. Do the factors first and then do the sums. And you'll get this, you'll get a sum that's equal to the addition of the factors. Plug it in here and you've got your answer.
Can't you do the same thing with the negatives?
Yeah, sure.
Why'd you do the positives on this one and not the?
Only because, that's a good question. Only because they're both positive up here.
Oh, okay. I just
Plus
want to
8
check.
plus, yeah, no, it's a good question. But they're both positive up here, and that's why I did the positives. Sometimes you'll have some, one will be negative, one will be positive. That's where you definitely are going to use the negatives and positives. Okay, does that make sense? You should write all this down so it sort of makes sense to you. This is the thought pattern you'd use. Figure out all the factors. That's why we talked about factors so much. And then the sum is just the sum of those factor values. Plug it in, and sure enough, it works, right? You don't have to do this step here. You just have to plug it in right. Give me the factored version. Do you want to work on another one?
Yeah.
Okay, give me another one in that book here, on that page, because those work. So see, sometimes you'll do this and you'll get, there's no X value available. That means that parabola does not cross the x-axis. It means it's got imaginary numbers. It's up in the air someplace. We don't care about those right now. Sometimes it'll just cross right at one point, so it'll be the same value. I mean, there'll just be one value for it. But most of these, I think, they all have values. So give me another one.
23.
Okay, what's the parabola?
It is x squared
Okay.
minus 12x
Okay.
plus 36.
Okay, got it. Okay, so the first thing we do, we look at that 36, right? What are the factors that make 36?
6 and 6.
6 and 6. What's another couple factors?
Let me write it down. Hold on, I'm trying to think.
It's okay. That's what we're doing.
12 times 3.
Perfect. 12 and 3. Thank you, Kathy.
Yeah.
What's another one?
8 times 4.
No, that's 32.
Okay.
But what about 9 times 4?
Ah,
Right?
Yep.
So it'd be 9 and a 4. What about an 18 and a 2? These are all the things you got to go through. And the other one would be a 36 and a 1. Right? Now look at your sum part. The sum has to equal 12.
6 and 6.
6 and 6. So this is going to be a really easy one, right? We know it's just going to be like this. That was an easy one.
Well, now it is.
Okay. And this is an interesting one because this really only has one solution, right? So if you plug in -6 here, the solution is x is equal to -6, right? Well, what does that mean? How can they both be equal to -6? That one's equal to -6 and this one's equal to -6, right? Why do you think that would be? Any ideas?
Because they want to trick us.
No, they want to trick you.
I have no idea.
No, it's not the answer. Why do you think?
Because they're both both of them are adding.
Nope. You got to deal like this, right? This is
I give up.
Cartesian plane. Okay. Well, what it means is that it only touches the x-axis one spot. This parabola goes up like this, right? It could go up like that. This would be 6. Or excuse me, I'm over here. This would be -6. So I'm on the wrong side. In other words, it only touches at one spot. Forget this.
Oh, and it needs to.
You know what I'm saying?
Mm-hmm.
Like can't do this very well. -6 is over here. So it'd be like this, right? That parabola would go up like that. Only touches one spot. There's some deals where it won't, it's an imaginary number. In other words, it doesn't touch any place. It has an imaginary number involved with the answer. So that means it's up here or it's way down here. It just doesn't relate to that x-axis at all. So there's three possibilities. One, it has two answers. One, it has one answer. One, it has no answers. Okay? You can only have three different possibilities. In the real world, answers are always one or two. Okay? But there's some instances where it's not a real world issue. It's a different kind of issue. It's a complex number is what it is. We don't care about that right now. Okay? Does that make sense? So that's how you do these. They're not any more complicated than that, but you have to do this process. Factor, sum, right? And sometimes I can just look at them and figure out what the answer is after you do it enough. You know, it just becomes really intuitive to you. I mean, it sort of get a little nerdy, I guess, but you know, it's just the way it works. And here's the other thing too. No, these are all in the form is equal to 0. So you don't have to do any rearranging, you know. But look at this number 24. I can look at this thing and say, it's going to be a 6 and a 1. No, excuse me, it's going to be a 7 and a 1.
You wrap it back in plastic.
Yeah, it's going to be a -7 and a +1 is going to do it for this one. You can something you get to the point and you just look at them and figure it out. This one here, 37 and a 5. 7 and a 5 is going to be the answer for that. 7 5 is 35. 7 minus 5 is 2, right? You can just look at them. This would be a 4 and a 3, right? This one down here would be an 8 and a 4. 8 times 4 is 32. 8 minus 4 is 4. Anyway, that's how you have to do these, okay? And there's a couple down here. What they're asking here is just put in these values here and make sure it works. And if it does, then it's the set, right? That's all you
got it.
31. You don't have to do the factoring. You're just plugging in numbers at that point. That's all you're doing. Okay. Look at 34. This has there's a lot of problems like this when you get into higher algebra. Figuring out the area of something where you've got a variable involved. So that we know the area is equal to length times width, right? So we know that it's going to be 2x minus 7 times this value. And we're given what the value, we know that this value times this is equal to this. So you can go ahead and solve for this by dividing this into this. Oh, and they're giving you what the answers, okay, I see. They're giving you what the answers are. In this particular one, you're just going to plug in x plus 10 times 2x plus minus 7, see if it works. That's what you're doing with all these. Does that make sense?
Yeah.
Okay. Okay, let's move on to the next section. I'm going to do it lightly because some of the stuff in the next section is not going to be helpful to you in my mind. So I'm going to kind of belabor it at all. Okay. So we're on that next section now. Okay, algebra solving. It's almost just like little riddles, some of it, but the only ones we're going to look at are related to quadratic equations or something like that. So for your homework on this section, I want you to put down, I want you to do 1, 3, 6, and 8. I'm going to go right to the next page here. 1, 3, 6, and 8. I don't know why they spend so much time on some of this stuff that, anyway. I'll show you what I mean here. Okay. Instead of doing 5, I just want you to do 1, 3, 6, and 8, okay? Because those have something to do with a quadratic equation, or they're they shouldn't be complicated to do. Some of this stuff is not, it's not easy to do, and it doesn't make any sense. There's nothing to really follow. So why don't we do, well, let's do one together, okay? Okay, here's the question. A number divided by 2 is equal to 12 less than the original number. What's the number? How do you do that? What you want to do, I'll share with you. A number divided by 2. I'm going to get back to this page here. So a number, when you ever talk about a number, whether turn it into a variable, right? A number, or x divided by 2, it says it's equal to the difference between the number and 12, right? I can't remember what it says exactly, but you can model it like x minus 12. Okay.
No. Yeah, and then the other one was Nelson was 5 times as old as Maria. How old
Right.
was Nelson 6
Yeah,
years ago?
let's worry about this one first. So
I thought
what
one
you
we were
wanna do-
doing.
Oh, no, they're two different numbers, two different problems, aren't they?
Which one are we on?
Number 1.
Oh,
Sorry.
I was on something different.
Yep, it's number 1. So it's the number divided by 2 is equal to the number less 12. I think that's how it's worded. So you just set it up as an equation. You put x over 2 is equal to x minus 12. Okay, and you solve for x. So in this particular case, what I would do is I'd multiply everything by 2 to make it easy. So then left side I've got x, right side I've got 2x minus 24. Okay.
Yeah, X2.
Now I would subtract minus, because I want to end up with the variable being positive. So I want to subtract x from both sides. So it's going to be x minus x is equal to 2x minus x minus 12. Oops. By doing that, I get, sorry. Okay, I get 0 on the left-hand side, and I've got x over here. And this is actually 24, not 20. Yeah, this should be 24. So now on the right-hand side, I've got 0 is equal to x minus 24. But we're still not done yet because I want x by itself. So at this point, I'm going to add 24 to both sides. When I do that, I get x is equal to 24. Okay. That ends up being your answer on that one. Okay. Does that make sense? All I'm doing is just solving for x. And I'm getting rid of the fraction by multiplying everything by 2. You can keep the fraction. You can go ahead and move it over, and but it's cleaner just to get rid of those denominators, right? So you just end up with a whole numbers on top, and you just solve for x. Okay. Does that make sense? Kathy, are you okay?
I'm going over this step by step in my head, talking to
Okay.
myself.
Yeah, okay. Well, hopefully it's working for you. Okay. Okay. Okay, I'm going to stop sharing that and look at the next. Okay. Okay, the only other one I'm going to look at, like I said, I don't want you to spend a lot of time on these. 6 or 8. Let's look at 8. A rectangle garden below is twice as long as it is wide. So they put up here, they get length is 2 width, and width's over here. So you can say a W and 2W if you want. If the total distance around the garden is 120 feet, what's the width of the garden in feet? So how would you do that? You have to use the perimeter formula, right? What's the formula for the perimeter of this rectangle? What would that be? You're just adding up the sides, right? Does that make sense? So let me see, I've got 2W, and it's 120. So I'm gonna stop sharing that. Bear with me here. Okay, stop sharing this. We're almost done, people, sorry. So you've got this, shoot, this rectangle. Just do it like that. And what do we know? We know one side is W, right? And the other side is 2W. That's what it says in the problem. What's the perimeter of this thing? Perimeter is just equal to the sum of all the sides, right? So you can say one, like the width, it's 2 times the width, right? Plus 2 times the length, right? And then you just go ahead and plug in what you got. Ah, darn it, couldn't. So the perimeter, 2 times the width is going to be 2W, right? And 2 times the length is going to be 2 times 2W, right? It's going to be like that. Well, what's that equal to? That's going to be 2W plus 4W, right? What's that equal to? 6W, okay? So you know the perimeter is equal to 6W. And so what does it get? It says the perimeter is equal to 120, right? So now you know 120 is equal to 6W, right? So now you divide 6 into both sides and you get what W is. W is equal to 20, right? So this is 20 and this is 40. Does that make sense?
Kind of.
Okay, kind of. Again, it's just the perimeter, it's the outside length. So you're adding W plus 2W plus W plus 2W, right? And you're given what the total perimeter is. So this is solving for W. So this is 20 feet and this is going to be 20 times 2 or 40 feet. And then do a check. You've got 20, 40, 20, 40. 40 and 40 is 80. 20 is 100. 20 plus 100 is 120. Boom, that's the answer, right? So we haven't made any mistakes. We've done it. That makes sense?
Yeah.
Yeah. We'll get more on geometry coming up too. So you know,
Oh, good.
perimeter and areas of things, but this is just an application they give you. Okay, so I think with that, we're going to take a 10-minute break and then we'll do the quiz. And the quiz covers the stuff that we went over earlier in the pre-quiz, what we did last Monday. Okay?
Can you email me that, please?
Yeah, exactly. In fact, I emailed it to everybody at the beginning of the class. Yeah, thanks for reminding me.
Okay.
Yep,
Sweet.
you should have it. And plus it's in Canvas also, okay? And on this quiz, you can use your notes. I really want you to just understand how to do it all, okay? So come back in 10 minutes and we'll start, okay? Okay, 10 minutes. Okay, 9:42. I'm gonna stop the